Welcome back to the GCSE Maths Pro YouTube channel. In today's video, we'll be looking at some of the most common calculator topics for papers 2 and papers 3. As you can see, here is the list that we will be going through, and it's specifically for higher tier students. So the first thing to make sure that you're happy with is just basic trigonometry. This could also include Pythagoras or just SOHCAHTOA. So here I've got a slightly more advanced question. We need to work out the angle x to 1 decimal place. As you can see, that's over here. I'm obviously going to have to start on the left-hand side of my shape though. So using trig, because I've got angles and sides, here I could work out the dashed side because that one is then the same as in my second triangle. So that would be the opposite. I then also have the hypotenuse, which means I need to use sin. So I like to use my formula triangle just to work out what I'm actually going to type into my calculator. I'm looking for the opposite, so I'll cross that one out. As you can see, that means that my calculation would be sin 80, then multiplied by the 6.8, the hypotenuse. So in my calculator, I obviously get loads of decimals. I'm going to write down a couple of them, but try and keep the answer there. So 6.69 ... So as I said, now I know this dashed side, which means because it's a rectangle, I also know the other dashed side, which now relates to the triangle I actually want to focus on. So step 2, we're now going to again label the sides. Because I'm looking for an angle, it's still trigonometry. So we've still got the opposite, but this time we now have the adjacent, which means I need to use tan. So because I'm finding an angle, I cross out the tan bit. So tan of the angle x would be the opposite, which is my 6.69. I'm going to copy the decimals from my calculator though, not just round it at this point. And then over the 4.9. Bring my calculator back. As you can see, I've still got the answer there. So what I can do is just copy that in full, but I do need to do tan inverse because I'm finding an angle. Whenever you're finding an angle with any type of trig, you always do inverse. So to the power of -1. As you can see. So inverse, I've got obviously my answer copied, the 6.69 over 4.9, which now gives me my actual final answer. And because they said leave it to 1 decimal place, I can now round that to 53.8. So x is 53.8 to 1 decimal place. Now, another part of what I'd call basic trigonometry, i.e. SOHCAHTOA, is actually obviously harder when we use it in the context of 3D trigonometry. So this is obviously a 3D scenario, but we're still using SOHCAHTOA and possibly some Pythagoras. So work out the angle between AF and the plane ABDE. I wanted to highlight this exact example because often we get this angle between some kind of diagonal line and then a plane. I want you to be able to identify which angle that is actually referring to. So obviously I'm going to start by annotating the line AF. Do you see how that line goes literally diagonally kind of through the shape? So AF and then the plane ABDE, which is the base of this triangular prism. Now, it's not the angle like this. You will be looking in your 3D shape for right angled triangles, but they will only ever be kind of like flat on the base or vertically stood upright. We're not going to have like a diagonal one. Do you see what I mean? Like it's not going to connect to AB. That would be like a diagonal triangle, wouldn't it? Which is a bit messy. So what I would do is draw a diagonal line through the plane. Obviously, just make sure it connects to other line you've drawn. So the diagonal from A would have to go to E. That's then going to show me my angle. Do you see how that's my angle? Basically, it's FAE, that's the angle. Okay, so just draw a diagonal line across the base or the plane or whatever they're referring to. So now I've got that, you can see that's obviously going to make a right angled triangle. Let's label the other information I know. So we've got CB, so the height is 7.9. I've got AC, which is this diagonal here, 11.5, and then I've got an angle AFC, so A to F to C. Okay, so this angle here, so imagine AFC as a triangle. It's also like a flat triangle, isn't it? That one is 53, if you can see that. So I've labelled it all. I obviously am going to need to have 2 sides in order to find out an angle. So what can I find out about this triangle? Let's complete the triangle first. AFE. What can I find out about that triangle? Okay, well, I've just referenced to the triangle AFC, this one on the top here. That's a right angle triangle too, isn't it? I've got 11.5 and I've also got an angle, so I could use that triangle to find out another side. AC, the 11.5, is obviously the opposite. The one that I want to know is the hypotenuse, isn't it, of that triangle. Again, I'll repeat, AFC. There we go, I've made it orange. Hopefully you can see that better now. So we've also got this angle here, haven't we? This is part of my orange triangle, the 53, and I've got the 11.5. So again, I'm going to use sine. Even though it's a 3D shape, it's still just normal trig, isn't it? 2D triangles. So I want to know the hypotenuse this time. So that means to find AF, that's the side I'm trying to find, isn't it, so far, I would need to do the opposite, which was the 11.5, over sine of the angle, which is 53. And as you can see, that gives me 14.4 basically. Again, I'm going to try and keep that in my calculator if I can, but 14.4 roughly. Okay, so now I have one side of this pink triangle, don't I? I just need now to have one other side of the pink triangle. So you can see what we've already used. We've already used the 53, the 11.5. What else is there? We haven't used 7.9 yet. Actually, just looking at it, 7.9 for CB would be the same as FE, wouldn't it? Just because at the back of that triangular prism, it's obviously a rectangle. So I don't even need to do anything, that's just there. Okay, perfect. Let's get rid of everything we don't need. So I now know AF and FE. So I've got the hypotenuse and I've got the opposite again. So actually I'm going to be using sine again. But this time we're looking for the angle, aren't we? So I'm going to cross out the S. So sine of the angle, you could call it X if you want, call it whatever you want, is the opposite, which is the 7.9 over the 14.4. Now again, I'm not going to just put 14.4, I will copy the answer from my calculator. And because we're working out an angle, again, remember we need to do the inverse, so sine inverse, 7.9 over, and this is where I'm going to put the answer button because my previous answer was the 14.4 in full, wasn't it? So I've got 33.27. It hasn't said how to round it, so I might just again round it to one decimal place, 33.3. And there we are. Okay, so again, another step forward is then moving from basic trigonometry to sine and cosine rules. So that's when we no longer have right angle triangles, and obviously you're probably going to be towards the end of the paper as well. So work out the angle ADC to one decimal place. ADC, so that's the one over here. So when I'm looking at it, again, I would obviously have to start with the other triangle, otherwise why have they told me about that one? What can I find out that would help me get close to my angle? Well, obviously the line AC. Both triangles share that side, don't they? So that would make the most sense. So I'm going to label the sides. This is technically B. Then I've got angle C. This is side C. Technically that's angle A, so that's side A. However, if you have a look at what I've got, I've basically got two pairs, obviously including one that I don't know, which therefore fits into sine rule. In this case, just the B and the C bit, isn't it? Now, because I'm looking for a side, I will keep the side at the top of my fraction. So we've got side AC over, it has to be the opposite angle to match as a pair, sine 85. And then we know that the other side, C, is 8.8 over sine of the opposite angle, 59. And then obviously with sine rule, you know that you always have to rearrange it, don't you? Just have to multiply by this denominator to get AC on its own. So we still have 8.8 over sine 59. But I'm going to multiply by sine 85 as well. So as you can see, I've got 10.227. Again, low as a decimal, so I'll just keep that there in my calculator, but I'll write down a couple of them. So now I know the side that joins both triangles. If I now look at the second triangle, I have three pieces of information, don't I? I have three sides, and the one thing I'm missing is the angle. Whenever you've got three sides and one angle, that's always cosine rule. So you can see here, because we're looking for an angle, I've rearranged the formula. You can either memorize it as it is, or you can just take the formula from the actual formula sheet and then rearrange it yourself, but they normally don't give it in that format. So if you want to change any of the labels, for example, cosine rule is always based in the angle A. I would probably swap that to be A. This is obviously then side A. This can stay as C, and we'll just call that one side B. So to find cos of the angle A, well, we can call it ADC, can't we, to match what we've got? I would have to do 15.4 squared plus 16.7 squared minus the A squared, which I will use my answer button for, over 2 times the 15.4 and then the 16.7 again. Now again, because we're looking for an angle, I am going to do cos inverse. You can see I also still have my answer there, so I'll be using that. Cos inverse of all of this. So after all that, I get 36.87. It did say to leave it to one decimal place, so that's 36.9. So the angle ADC is 36.9 degrees. And the final part of trigonometry is obviously the trigonometric area of a triangle. Again, this formula will be on your formula sheet anyway. So the area of the triangle ABC is 135 centimeters squared. Work out the value of x. So actually we need to set up the equation and work backwards. Again, you might want to change the letters if you're not so comfortable with how to sub it in. So obviously that one is based in angle C. So we can call this one side A, and then we can swap this one for B, and then therefore that makes that side B. So the area is half A, which in this case is in algebra, so 2x plus 5, B, 4x minus 3, multiplied by sine of the angle C, which is 150. And then that equals 135, because I know the area is actually 135. So now I've got an equation. So I probably want to know what sine of 150 is. Okay, that gives me 0.5 or a half, which then multiplied by another half would be a quarter, wouldn't it? So we've got a quarter. I'm going to expand out these brackets. At this point, it's just algebra, isn't it? So 8x squared minus 6x plus 20x minus 15, and then obviously still 135. Now I'm probably going to multiply by 4 because I don't really want to have fractions or anything on this side. So I have 8x squared plus 14x minus 15. And then on the other side, this one times by 4, which gives me 540. And because it's a quadratic overall, I'm going to move across the 540. Now, because the numbers are so big, I'm going to not try and factorise this. I'm just going to put it straight into the quadratic formula, which is obviously another most likely to be calculated topic. So your quadratic formula is obviously on the formula sheet anyway, and that's what I'll type into my calculator. Now that gives me 15 over 2, or in other words, 7.5. Or I just go back and I just change it to a minus, don't have to retype it all in. I get minus 37 over 4 or minus 9.25. Now, because they've said work out the value, just one value of x, and we have a context of a shape, you just have to figure out which one of these does or doesn't work. Normally, it's obviously going to be the negative one. You can't have a negative side length. So therefore, my final answer for x is going to be the 7.5 because I know that that won't leave me with a negative side length. Following on with shapes, we have things to do with area of a sector or arc length of a sector, that type of thing. In this case, they've said the perimeter of the sector is 30.3 centimeters. Work out the angle theta. So this bit here, kind of similar to the previous one in the logic. If they've given us the perimeter, I'm going to create an equation, a formula for the perimeter. So the perimeter is when you add all the sides together. So we've obviously got the radius, which is 8.2. Then we've got another radius, which is another 8.2. And then we would have to add that to the arc length. Now, the formula for arc length isn't on your formula sheet. Technically, the formula for circumference is, you would just have to remember to take the whole circumference and multiply it by the angle over 360 though, so it's not too difficult. So in this case, we've got pi times diameter, or you can use 2 pi r. Same thing. So I know the diameter is 16.4, because I just obviously have to double it. 16.4 pi, let's put that in brackets, times, I don't know the angle, so I'm going to leave it as theta. You can obviously put x if you prefer. And then I know that that equals 30.3. So I've set up my equation. Now the only thing that's missing is to find the angle. So first of all, I'd probably subtract the 8.2s. So moving those across gives me 13.9. Now you can do this in different ways. You can obviously divide by 16.4 pi first. You can times by 360 first. You could divide by those two as a fraction of each other. It doesn't really matter. I'm just going to take them as a whole fraction and do it in one step. So the actual angle should be 97.1 degrees. 97.1, I've just rounded that to one decimal place. And there we are. So again, just set up the formula based on the context and rearrange. Now we've got area of a sector, so kind of compound area as well. Work out the shaded area. Again, you can see the formula is over here. It's now pi r squared times theta over 360, or the angle over 360. Again, the area of a whole circle is on your formula sheet, but this bit here to make it a sector isn't. The angle over 360 is not, so just remember that piece. So working out the shaded area is basically the whole sector minus this kind of semicircle cutout, isn't it? So let's do the whole sector. We've got pi times the radius. Now the radius for the whole sector is 6, isn't it? So just be careful of that. Times by the angle, which we've got now, is 72 over 360. Now I'm just going to write down the simplified version in terms of pi so I don't round my answer too soon, because otherwise it's just a load of decimals. So 36 over 5 pi. Now for the area of the semicircle. So that one is obviously just half a circle, so you've got pi r squared over 2, but the radius is actually not 5, it's 2.5, isn't it? So just be careful of that as well, because the 5 is technically the diameter for that semicircle. And again, in terms of pi, that gives me 25 over 8 pi. So the final thing I need to do to find just the shaded bit is to subtract them. Now that it's my final answer, I will convert it into a number, so that's 12.8 centimeters squared. Obviously now we're going to be moving on to volume, but what I've noticed is they tend to have kind of area or volume at the start of the paper with some kind of context here. So the cylindrical container is 3/4 full of water. Bucket holds 5 litres of water. What is the greatest number of buckets that can be filled with water from the container? Okay, so quite a lot going on here. Obviously, first of all, volume of a cylinder. I think there's a version of this on your formula sheet actually for a volume of a prism, but obviously it would be the circle pi r squared. So we've got the radius of 0.2 meters. However, I might actually prefer to have this in terms of centimeters. That's just my preference. I'm going to use centimeters here. So my radius is 20 squared, and then times by, obviously in this case, the height, which is 90, which I'm going to leave in terms of pi. So that's 36,000 pi centimeters cubed. Now they have then said it's only 3/4 full. So 3/4 times by 36,000 pi. You can kind of work that out yourself. Just 3/4 of the 36,000 is 27,000 pi. Okay, so that's how much water we have in the cylinder, in the container. And then now we're looking at the bucket. So the bucket is 5 litres though, so we also need to do a conversion, which is why I preferred to use centimetres instead of metres, because I know the conversion between 1 litre is 1,000 centimetres cubed. So I'm going to convert the 27,000 pi into litres. So we can just divide that by 1,000, which is obviously 27 pi, but I might just actually look at the numbers now. 84.8 litres. Okay, so how many times can I fill up the bucket? Finally, I'm going to do 84.8. Obviously, I'm going to use the whole of the decimals, right? But my calculator, but I'll just write that down for now. Divided by 5 gives me 16.96. Now, this is where we had to figure out how to round it. Because it said what is the greatest number of buckets that can be completely filled with water from the container, well, technically 16 can be completely filled, and then the 17th bucket is only 96% full, isn't it? So, even though I get 16.96 ... the actual answer would therefore be only 16 buckets, wouldn't it? Because I haven't filled up to 17 fully. So it's only 16. Okay, obviously a really obvious one for paper 2, paper 3 is compound interest. You do actually have the formula for this on your formula sheet, so you can use that. I've just written it in my own format. So Amy wants to invest 4,000 for 6 years. Which account would offer her more interest? So we've got two options. Bank 1, 2% compound interest each year, and then Bank 2 is actually split. 3% compound interest for 2 years, and then 1.2% compound interest each year after. We're obviously talking about 6 years, aren't we? So I just like to split this down the middle and work them out separately. So Bank 1's obviously the most simple one. I'm just going to sub in all the values. So we've got the initial amount is obviously £4,000. Times by 1 plus 2%, as obviously a decimal is technically 1.02. You can write it however you want into your calculator. And then to the power of 6, which will give me £4,504, and I'm going to round that to 65 for 2 decimal places. Then the second one is just split compound interest, so we're going to deal with them separately. So for the first 2 years, we're obviously still starting with the 4,000. We're now multiplying by 1.03, which is adding 3%, isn't it? But that's only for 2 years, which gives us 4,243.6. And then I'm going to take that and use that as my starting value for the next compound interest formula, which is now for 1.2%. So that's 1.012. And then that's the power of 4 years, because there's 4 left, isn't there? So take my answer, and I get 4,450.99, let's say. So they have asked who has more interest. Now, because for both of them we did start with 4,000, you can effectively just compare which value is bigger, can't you? So we can clearly see there's more interest has been added with Bank 1. So you would have to choose, therefore, Bank 1. Now we've got depreciation, which, as you can see, the formula is basically the same, except we now have a subtract instead of an add over here. This one obviously in itself isn't on the formula sheet. You just have to adjust the compound interest formula with the subtract. So a swimming pool holds 60,000 litres of water when full. The pool is drained at a rate of 9% per hour. Work out the amount of water left in the pool after 16 hours. So it's now in terms of hours, but it still works the same. Our initial amount is still 60,000. Times in by, now because we're losing 9% per hour, if I did 100% minus 9%, that would give me 91%, which as a decimal is 0.91, isn't it? That's why we're subtracting, we're losing, in this case, water. Then it's to the power of the time, which is 16 hours. As you can see, there's only 13,268 litres left. So it's really easy, just use the same formula. So we've obviously got upper and lower bounds, given that you can see the decimal places. It's most likely going to be a calculated question. So by considering bounds, calculate the value of g to a suitable degree of accuracy. And then we've got this formula here for g. We've been told f and h. When it says by considering bounds, we normally have to work out both the upper bound of g and the lower bound, and then make a decision at the end as to what our final value will be. So I need to know the upper and lower bounds for f and h. So for f, the upper bound is correct to one decimal place, so that'd be 5.95, wouldn't it? Lower bound's obviously then 5.85. H, the upper bound would be 6.275, and the lower bound's then obviously 6.265. So now I just need to figure out what combination I need in order to find the biggest value of g and the lowest value of g. So the upper bound of g, to get the biggest possible answer, I would need to have the biggest possible numerator and then divide by the smallest possible denominator. So I need to do 5.95, square root of that, over 6.265. As you can see, I get loads of decimals, so I'm going to write down probably 4 or 5 decimal places, 0.38934-ish. 38934. And then the second one is just then the literal opposite, isn't it? To get the lower bound, or the smallest possible value of g, I would need to have the smallest numerator divided by the biggest denominator. So literally swap them. So the square root of 5.85 now, over 6.275, which is 0.38544. Okay, so now I've done that, I just need to look at both my answers and see to maybe whatever certain number of rounded decimal places, just have a look what they would both equally round to. So I think the most obvious one here is probably 2 decimal places, or in other words, 2 significant figures. They'd both round to 0.39, wouldn't they? When rounded to 2 decimal places. G is 0.39, and then normally asks for a reason, and the reason is because when rounded to 2 decimal places, or you could say 2 significant figures, they are both 3.9. Or some version of that, basically. You don't have to word it exactly the same, but some version of that, because when I rounded them both by the same amount, it gave me the same answer. Okay, iteration, again, a really obvious one to be in the calculator paper. I have got all 3 possible questions here. So part A is to show that the equation x cubed minus 5x plus 2 equals 0 has a solution between x is 0 and x is 1. This is really straightforward. You just sub in x is 0 and x is 1. So let's do that. So when x is 0, obviously you've got 0 cubed minus 5. You just write it down just so that they can see the working out, right? You can see that that would give you 2, wouldn't it? You don't even need a calculator, really. And when x is 1, 1 cubed is 1, minus 5 times 1, so that'd be minus 4 plus 2. That would give you minus 2, wouldn't it? Now, the whole point of this is when, when it equals 0, for one of them we found out that it was above 0 and the other one was below 0. So you just have to put a little conclusion that there was a sign change. One is positive, one's negative. Therefore, that means that you just copy this bit, that there is a solution between x is 0 and x is 1. And that's it. So you get 2 marks normally for this, 1 for subbing it in, 1 for your conclusion. We've then got part B, which is show that the equation x cubed minus 5x plus 2 equals 0 can be arranged to give x is equal to minus 2 over x squared minus 5. So you just have to kind of figure out what they've done. Normally they've rearranged it in kind of an odd way, but you just have to try and look at both and see what's happened. I think what they've done is they've obviously subtracted the 2. I think that's the first thing, isn't it? So they've moved the 2 across by subtracting it. And then, to leave an x on one side and have x squared on the other, I think they've just factorised out the x. Because then do you see how I get this bracket with x squared minus 5, which is the same as that denominator? And finally, just divide by that bracket. So x is equal to minus 2 over x squared minus 5. And that's it. You just have to figure out how to get from A to B. Now, the main part of iteration is obviously this question here. So starting with x0 being 1, use the iteration formula. Xn plus 1 is equal to minus 2 over xn squared minus 5, 3 times to find an estimate for the solution of x cubed minus 5x plus 2 equals 0. So we're just using this rearranged version from part B to find a solution. Now, it's like a sequence really. They're saying you're going to input the previous number in order to find out the next number. So we're going to do it 3 times. So we've got x0 there. We're going to find x1 first. Do you see how that would be minus 2 over the previous number, which was x0, so that's 1 squared, minus 5. And then every time you'd input your answer into the formula again. So there is a specific way to set this up on your calculator. So what I would normally do is put whatever your starting value is, just there, make it equal to that, and then type in your whole formula. So here I've got minus 2 over, now where it says x, that's where I'm going to put my answer button, squared, minus 5. When I press equals, so x1 is equal to 0.5, so that's my first value, 0.5. And then I don't necessarily have to write out the whole thing for the second value. I'm just going to press equals again, and it will input 0.5 as my next answer, which then gives me, oh, massive decimal, so write down maybe 5 decimal places, 0.42105. And then once more, press equals again, 0.4147 for x3. Now, they've said find an estimate, just one answer, so that would be your final answer. So the number 3, the third time that you've done it, that would be your final answer. So in this case, that would be 0.4147 for your answer. Now, our final question is on histograms. The histogram shows information about the times taken by some students to finish an exam. Find an estimate for the median time taken to finish the exam, so median. So we're going to want to work out our frequency table. Obviously, histograms, we're going to use our formula triangle. Frequency is always at the top. Frequency density, class width. Now we're trying to find the frequency, right? So crossing that out, I'm going to multiply together the x and the y axis. So for the first one, we've got 0.2 times 10, which is 2. Then we've got 0.7 times 10, 7. Then we've got 0.8 times 20, so 16, 0.9 times 10, so 9, and finally 0.1 times 30, which is 3. Okay, we also want to know our total frequency, so if we add all of that together, we get 37 as our total frequency. So what you can do when you've got an odd number, if you want to, you can add 1 to it, so you can make it, in this case, 38. Now we want the median, which is halfway, isn't it? So I'm going to divide that by 2. 38 divided by 2 is 19. So that tells me I want the 19th student. So where does the 19th student lie? In which of these bars? In which of these rows? Well, we've got in order of time, the first 2, add another 7, that's the first 9 students, so still not enough. Add 16, that would give you 25 students, wouldn't it? So that would include the 19th student. So now we know that the 19th student is somewhere between 40 and 60 minutes, but I want a more specific estimate. So now I need to figure out, well, how far into this category is the 19th student? We just said that we've got 9 people in the other 2 rows before. So if you take away 9, that's 10 students left, isn't it, that are into this row. So our 19th student is technically the 10th student out of 16 in that particular row. Then we just multiply that by the class width, which happens to be 20, and that gives you 12.5. Now, that is in terms of minutes now. However, obviously, we just said it has to be an answer between 40 and 60, so not literally 12.5. What that is it's saying it's 12.5 minutes into this row. So starting at 40 minutes, isn't it? So you just have to add on the lower limit of that row, that category, and that will give you 52.5 minutes. So that's my specific estimate for the median, 52.5 minutes. You can do the same with the upper and lower quartile. You obviously just change initially, instead of halving it, you would either find a quarter or 3/4. So there's a variety of calculated topics for you to make sure that you're happy with. Obviously, there is still the whole syllabus to check. Please don't limit yourself to just these topics only. Obviously, anything could come up. So make sure that you're happy with revising as much of the syllabus as you can. So thanks for watching this video. If you found it helpful, make sure to like and subscribe. And if you have any questions, please leave them down below.